Okay, so the rest of 2.4 is all about transformations. And so what these are doing is these are picking up a graph, moving it up, down, left, right, shrinking it, stretching it, flipping it around, left and right, up and down. So that's what we're doing is it's all about graphing. So the transformations are all about graphing. So one thing that I wanted to start off with just to make things a little bit simpler so you can just kind of visualize the first general example. I'm going to give you two different graphs and show you the different transformations between the two, okay? So first of all, I'll just go ahead and do a parabola just because that's the one that we tend to know and love. So this is my f of x equals x squared. Fairly simple, right? And so then what I want to do is I want to show you what could happen when we shift that around. So what if I were to give you, and I'll call it g of x, you could still call it f of x if you'd like, I just wanted a different letter. What if I were to give you now instead something like x minus 1 squared? So what happens with that? What is the transformation that's involved? Notice that the only difference is that this has a minus 1 in it, right? So that minus 1 inside the parentheses, so when you have a plus or minus a number inside the parentheses, that's always going to be a side-to-side shift, or what is called a horizontal shift. So let's write that down, a horizontal shift. All right, now that is a minus 1, which means we're going to go to the right 1 unit. Now, if that were a plus 1, you would go to the left 1 unit. So all you are doing with these horizontal shift is I'm taking this red parabola that I have over here on the left, I'm picking up the parabola itself, and then I'm going to move it to the right 1 unit. Now you'll notice if I did that, my parabola would look the same shape, only its vertex is somewhere different. That bottom point is somewhere different. Does that make a little bit of sense? Hopefully that makes sense. That's all what we're talking about is that horizontal shift, okay? So that's the simple one. It's called the horizontal shift, and that's when you have something that plus or minus a number inside the parentheses, okay? So now let's kind of expand that. Let's make that one step more difficult, okay? So I'm going to give you a graph, and again I'm going to talk about one more thing. I am going to give you now function, oops, sorry about that. I'm going to call it, let's say h of x, just for fun. I'm going to say h of x equals negative, parentheses, x plus 1 squared, okay? So I've given you this function, and the idea behind this is we are trying to graph these new functions using what we know about transformations. So before I even go to graph that, what I'm going to do in red is I'm going to graph what I like to call the original, the y equals x squared, the simple one, the boring one, the one that you know the shape of, right? So if that were an x cubed, it would look like a snake. If that were square root functions would look kind of like that, and so on. So we know what the x squared looks like, so I'm going to attempt to make that a beautiful x squared, forgive my imperfections, that's close enough. Okay, so there's my, oh, that's going to bug me, let me do it like this. There we go. There we go. Okay, so there's my y equals x squared. So what I'm going to do is I'm going to, in blue, I'm going to write down what the transformations are. Now we have a plus 1 inside the parentheses, like we were talking about. When it's inside the parentheses, it is a horizontal shift. So I'm going to write that a horizontal shift. Because it's a plus 1, we're going to go to the left 1 unit. Okay, and then we also have what we're noticing, the other difference in this function is we have a negative out front. So that negative out front is actually going to flip the graph. Oops, I should have written that in blue. Not that it really matters. Okay, it's going to flip the graph upside down. That's what the negative on the outside does. It just takes the graph and it flips it upside down. So let's go ahead and graph that. I'm going to graph that in a different color so that we're not too overwhelmed here, right? So a horizontal shift of left 1. So I'm going to take this graph and I'm going to move it to the left 1. So notice I took that vertex and I moved it to the left 1 unit. And then all I got to do is flip it upside down. That's it. Ta-da! Pretty easy, right? So that's the idea of transformations. Now, of course, I would ask you for a couple more things. So let's talk about the domain and range, just because we know that's going to happen. I'm going to write that still in green because what I'm trying to find is the domain and range of my h of x. So the domain of h of x, okay, that's my shorthand for the domain of h of x. Now, as you'll notice, because this is a polynomial function or a parabola or quadratic function, The domain is all real numbers. Any x value I could plug in, no problem. It's the range of my h of x that's going to be a little bit different. So let's take a look. Notice what my h of x is doing. It looks like it's going down forever. So that's going to go all the way down to negative infinity. But what's the last y value I reach? As I go up to the very top of this, before I start coming down, it looks like that last y value I reach is 0. And I've included that because I did get there. Okay, so I know it's kind of a lot all in one page, but that's the concept, that's the general idea for what these transformations are doing. Now, one more that I want to do, just one more. So let's go ahead and, oops, this one doesn't have the graph drawn, sorry about that. Okay, so let's go ahead and do one more. What I want to do now, and I'll call this, I'll go back to f of x. Let's call this f of x equals, let's do the square root of x plus, let's do a minus 3. Okay, so what I'm going to do, again, same idea. I'm going to go ahead and graph the original, the simple one, the one I know that it looks like. That's my square root of x. If you're not sure what that graph looks like, I have a whole little spiel posted on D2L about the basic graphs. And you can also use your graphing calculator if that's easier. But the square root of x, or you can do an xy table as well, right? Square root of 0 is 0, square root of 1 is 1, square root of 1, 2, 3, 4 is 2, and so on. And the graph looks like that. Okay, so now let's talk about those transformations, right? Here I have nothing inside the parentheses, so there is no horizontal shift. There's also not a negative on the outside, so it is not flipped upside down. But I do have a subtract 3, and that subtract 3 is what is called a vertical shift, okay? And in this case, it is going to go down 3 units. If that were a plus 3, this would go up 3 units. It's pretty self-explanatory. So I'm just going to take my graph and move all of those points down 3 units and draw the same shape. Ta-da! So that's the idea. You've got the horizontal shifts, the vertical shifts, the flipping up and down as well can also help in. There's a few other things that we can talk about. One more thing, I won't graph it, but just so that you can see what they're going to look like. If I were to have, let's say, a function f of x equals 2 times x squared, then this would be what is called a vertical stretch. Oh, I spelled that wrong. Vertical stretch of 2 units. Basically what that does is it takes your regular parabola and then that's going to turn it into a skinnier parabola. So I've just made it skinnier. I've doubled the height, basically, is what I've done there. So that's another thing right there. Another possibility that could happen for those same types of things would be then smaller number. Let's say we're 1/2 x squared. So that is what is called a vertical compression. Okay, and so what that does is it takes my normal y equals x squared and it turns it into something it's shrunken, basically, so it turns it into a fatter parabola. So we've got vertical compressions, stretches, horizontal shifts, vertical shifts. Reflections are the upside down, that's what we're talking about there. So there's the idea for transformations. Ta-da!